discussing bromination, a chemical reaction where bromine is added to a compound. This process changes the properties of the initial compound, resulting in a new product with different characteristics. Let's start with the hazards associated with this reaction. Chemical hazards. Bromine is a violent oxidizer and highly reactive with organic compounds, posing significant fire and explosion hazards. Material compatibility. Bromine is incompatible with materials like aluminum and reacts violently with water, so careful selection of equipment materials is crucial. Exposure risks. Exposure to bromine can cause severe respiratory irritation, burns, and chemical burns upon inhalation or skin contact. Environmental impact. When exposed to water, bromine releases toxic fumes, posing risks to the environment and nearby communities. Equipment failure. Malfunctions in scrubbers, pumps, or other safety equipment can lead to bromine leaks and exposure hazards. Human error. Improper handling, transfer, or storage of bromine can result in accidents, spills, and exposure incidents. To mitigate these risks, we implement various safety controls. Use borosilicate glass or polyvinylidene fluoride, PVDF, for columns to ensure corrosion resistance. Utilize borosilicate glass, carbon steel, PTFE lined, and PVDF for pipe work to ensure compatibility with bromine. Provide a dedicated storage room with a scrubber facility for the safe storage of bromine. Install view glasses, splash guards, and flange guards on all transferring and charging lines to prevent exposure. Equip the facility with roof-mounted fire extinguishers and standby scrubbers for emergencies. Use non-aqueous heat transfer fluids in the reactor facility to avoid reactions with water. Provide wind socks to assist wind direction and prevent bromine dispersion. Install bromine detectors and alarms to monitor bromine levels and promptly detect leaks. Plan for dedicated cleaning areas with neutralizing agents and catch pots for emergency dumping. Install a dump tank for the safe containment of hazardous materials. Utilize bromine detectors and alarms to monitor levels and initiate emergency response if a leak is detected. Activate emergency shutdown systems to stop bromine flow and isolate affected areas, close valves and shut off pumps. Sound alarms, announce evacuation procedures, and evacuate personnel to designated safe assembly areas. Activate the emergency response team to assess and contain leaks, ensuring they are equipped with appropriate PPE and respiratory protection. Personal protective equipment, PPE. To protect against bromine exposure, use respiratory protection, hoods with breathing air to prevent inhalation of bromine vapors. Hand protection, chemical-resistant gloves to protect against skin contact. Footwear, gum shoes or boots to prevent contact with spilled bromine. Conclusion. Bromination processes require stringent safety measures due to the hazards associated with bromine, a violent oxidizer. By implementing appropriate engineering controls, careful equipment selection, and proper personal protective equipment, we can effectively mitigate the risks associated with bromination, ensuring the safety of personnel and the surrounding environment.
This is all about today's topic. Thanks for watching Funny EHS Info. And don't forget to subscribe our channel to get immediate notification of our videos. Share our videos to your friends and colleagues to create safety awareness. If you have any questions and requirements, please comment in comment box.